Hello, myself N.S.L. Karthikeya Reddy. As part of the NLP theory day, now I'm going to present about the topic of machine translation, transforming global interactions through NLP. So, as per the introduction of machine translation or MT translates or automates the conversion of text or speech from one language to another. This technology is crucial for facilitating cross-lingual communication, which is essential for globalized industries. The goal of MT is to provide accurate, context-aware translations that maintain the meaning across different languages. So now let's dive into the evolution of machine translation and understand how far we have come. To understand where we are today with machine translation, it's helpful to look back. Earlier systems were rule-based, focusing on grammatical structures to perform translations. However, in recent times, there's been a shift to data-driven approaches with neural machine translations, NMT, becoming the dominant technique. The scope of machine translation has grown to power multilingual websites, apps, and other communication tools, enabling easier access to information for people worldwide. So, this is the general diagram for application of machine translation. So we will be using NLP techniques or AI ML models to convert one language to another language. So coming to the types of machine translation, uh, there are basically four types of methods, namely rule-based MT, statistical MT, neural MT, and combined hybrid approaches. So first, rule-based machine translation. This method relies on linguistic rules and grammar. The advantage is that it's highly controlled and can produce grammatically accurate results for structured languages. However, it's rigid and lacks context, and creating manual rules can be quite labor intensive. It can be hard to create the rules for the model to work. And coming to the next model, statistical machine translation or SMT. It uses probability models derived from bilingual text corpora, and it adapts well to a different language pairs by learning from large data sets. But it struggles with rare words and idiomatic expressions. And third one is neural machine translation. NMT, on the other hand, uses deep learning models to understand the semantic meaning of sentences. It's more fluent and context aware, but requires a lot of data and computational power for training. And coming to hybrid approaches, uh, it combines the other models such as RBMT or SMT or with NMT to improve accuracy and reliability. So it basically leverages the advantages of individual models to improve the overall accuracy. And coming to this is the oral flow or oral types of machine translation. So coming to the neural machine translation, it is actually based on the encoder-decoder architecture, where the encoder converts an input sentence into context-rich vectors, and the decoder uses these vectors to generate the translated sentence. An important component for this approach is attention mechanism, which helps focus on relevant parts of the source text during translation, particularly in long or complex sentences. And one of the major benefits of NMT is its ability to produce translations that are closer to natural human language, thanks to its ability to handle context and semantics effectively. So this is the general architecture of the NMT. As we have discussed, it uses an encoder-decoder architecture. So let's say example, imagine we want to translate a sentence from one language to another. Here the encoder takes the original sentence, processes each word, and converts the entire sentence into numerical values, which to numerical values called context vectors. So these vectors contain the meaning of the sentence. Next, the decoder takes these context vectors and generated the translated sentence word by word. So here we have taken an example sentence like Bush held a talk with Sharon. So divide the sentence into individual words and applied. So as per the diagram here, it is having the encoder, and here is the decoder part, and the decoder part actually uses the attention mechanism to improve the accuracy, and this mechanism helps the decoder focus on most relevant parts of the input sentence. So during translation, especially when dealing with long or complex sentences, this approach allows NMT to provide translation that are more accurate and sound more like natural human language. So this basically uses neural models which have more hidden layers for complex pattern identification and recognition. So coming to the real world applications of machine translation or NMT. So let's consider a real world example of NMT such as Google Translate, which we all use in our daily life. Google transition from statistical SMT to neural machine translation, which significantly improved its translation quality. Today, Google Translate offers real-time translation across 100 languages and can handle text, speech, and even images. NMT has made this service much more accurate and contextually aware. So, some of the other real-world applications of machine translation include uh, it is used in e-commerce such as Amazon and Alibaba use machine translate to translate the product description, customer reviews, and queries, thereby enhancing cross-border shopping experience, which ultimately improves the customer satisfaction. One other sector is healthcare, where MT is used to translate medical records and doctor-patient interactions, which is invaluable in multilingual settings. For instance, a doctor can treat a patient speaking in a different language by translating prescriptions and diagnosis. Some of the international organizations also use MT, the United Nations and European Union rely on MT to translate official documents and facilitate multilingual meetings. And commonly, it is used in social media like Facebook and Twitter to translate posts and comments, connecting people globally regarding of language barriers. So some of the challenges in machine translation include context sensitivity. Sometimes language have often words with multiple meanings, and MT can struggle to capture the correct nuance. For example, the word bank could mean a financial institution or the side of a river. And next, idiomatic expression. Phrases like piece of cake or kick the bucket are challenging for machine translation to translate meaningfully. So, other challenge is low resource language. Languages with limited digital resources, such as indigenous languages, are often poorly supported due to lack of training data. So, with lack of training data, in the sense, some of the region languages of India, such as Telugu, Tamil, they lack the good quality amount of training set to train the model. So another challenge is domain specific translations. Fields like law or medicine require high accuracy, which machine translation may struggle with, particular for niche technology or terminology. Uh, Cultural context. Sometimes translation miss cultural references, which can lead to misunderstandings. So, looking ahead, machine translation is evolving in interesting ways. So, some of its future directions include zero-shot translation. So, it is the ability to translate between languages without direct example. For instance, translating from Swahili to English, Swahili to Hindi using English as a bridge. Google has introduced this capability for some language pairs, and real-time speech translation. It helps in improving the accuracy and speed of translating. Live conversation is a key focus area. Platforms like Microsoft Teams and Zoom are already integrating real-time speech translation into their services. And next is multimodal translation. This involves translation that combines text, speech, and images. For example, Google Lens, which can translate text and images in real time, and personalized translation. Future machine translation systems can adapt to users' preferences, tone, and context, offering custom translations for specific industries or individuals. So, coming to the conclusion, to conclude, machine translation is transforming the way we communicate across languages, making information accessible to more people than ever before. Neural machine translation has revolutionized the field with more natural and accurate translations. Looking forward, advancements in zero-shot translation and real-time speech translation will make MT even more precise and culturally aware. The global relevance of MT is undeniable as it is used in our daily life. As it continues to break down language barriers across business, healthcare, education, and more. So, thank you for listening. Thank you, sir.